Hello, folks. Thank you for coming. I see that people are coming in right now. So as everyone's getting set up, I'm going to start in with an intro, and we can't wait to hear from Pete with Aircuity. Thank you for coming to the Healthy Building webinar series. Today, we're going to be speaking about measuring what matters, measuring and monitoring vital steps to measuring your energy and your indoor air quality. So just for you guys to know that we do these about every week when COVID was just first starting, and now we're going to about every month or so. So keep an eye out for what we have going on. And as always, let us know. If you want to hear about something, let us know. We'll get the professional in front of you. We'll make it happen. We really care about what you are interested in as our members. So we want to thank Quality Air Service, Inc. for sponsoring this event today. They are an amazing group of gentlemen, and since 1977, Quality Air Service, Inc. has been serving Michigan and North Indiana. They specialize in commercial and industrial equipment sales and services for critical airflow environments. They're a team of highly skilled and certified technicians who are ready to provide installation assistance, startup services, field certifications and verifications, as well as continued maintenance for years to come after that. They have a deep knowledge in the health and hospital arena, which bodes very well with any facility who is looking to have a safer building post-COVID. So thank you very much, Quality Air Services, for sponsoring today. And if anybody wants to hear more about that, I'm happy to take any of your questions. Pete, will you please go to the next slide? So a few introductions, folks. My name is Jillian Gim. I'm the program manager for the U.S. Green Building Council of West Michigan. And today we have the honor of having Pete Hmelyar, the Vice President of Sales for Aircuity, to join us today. Pete is an amazing guy from Indiana. He's the Vice President of Sales for Aircuity, Inc. He joined the company in like November 2000. So he's been there for quite a bit. He is responsible for all sale activity in Aircuity solutions in all of United States and Canada. Pete has over 30 years of sales management experience in the building, healthcare, and laboratory controls businesses. So we're really looking forward to having the expert tell us today about air quality and air quality testing and monitoring and what you need to know about your building. So Pete, thank you. Oh, before I turn it over to Pete, so folks, remember, you have the chat box and you have the Q&A. If a question comes to mind, don't wait, just throw it in the Q&A. We'll get to it, I promise. I really care about making sure your questions are answered. And also, when you do the chat, take note if you're sending it to just the moderator, which is me, the panelists, which is me and Pete, or all the audience. So be mindful of when you're doing that in the chat. And there's going to be a survey coming out after this. So let us know what you thought, what you learned from this, what you want to see more of, and how we can improve. We really care about hearing what you have to say during this time, and we want to make sure that we're able to provide you all the resources you need. So without further ado, thank you so much, Pete, for taking your morning to talk with us today, and we're really looking forward to hearing what you have to say.
Thank you very much, Julian. It's quite an introduction there for both Quality Air, which we're proud to be representatives there, as well as myself. So it's going to be hard to live up to that with this presentation, but I'll do my best. And as we said, we want to make sure that you send questions or thoughts that you want to talk about after this presentation, because it's important that you get out of it what you need and hopefully learn a little bit along the way. This is something that probably many of you have seen through various webinars or presentations you've sat through, but it's good to start out and frame this, and that's the fact that we spend so much time indoors, and when you think about indoors compared to outside, there are much higher level of pollutants inside, and that's really where we're trying to go, is to make the inside better. The inside being buildings, specifically the buildings that you either work in, or you send your children to school in, or your son or daughter off to college in. All these areas are critical, and we obviously live, work, learn, and we're in those areas the most, especially those of us, I'm actually in Illinois, in Chicago area, those of us that live here in the Midwest and have those lovely winters where we sometimes are indoors forever because you don't want to be outdoors. So anyway, you know, the other thing I want to start with to frame this all is kind of where we've been in the last 20 years or so and where we're going forward with regards to buildings. So for many years, you know, starting in the 80s and on through the 90s and early 2000s, the real focus was on building and designing efficient buildings. By that, I mean, they're tighter buildings. We were using lower amounts of outside air. And then LEED joined us, you know, back in the early 2000s. And LEED designs were all about making the buildings better, more efficient. Obviously, many of you know about LEED because this being a USGBC sponsored event, I think most of you have, you know, LEED's been around long enough that we're not going to spend much time on it. But it was all about net zero designs, lowering the carbon footprint, making the building efficient. And then what happened about 2014 and 15 and so, the focus started to become switched to more occupant health and wellness. It was driven by two things. There was a COG study, the cognitive study that was done by Harvard School of Public Health, which we'll touch on a little later. And at the same time, the WELL standard came about 2000, you know, about four years ago, 2015, 2016 in that area. And WELL was about health and wellness for the inhabitant or the people in the buildings. And so what started to happen was that we moved to higher amounts of outside air. We started looking and saying the buildings are tighter, we're not getting a lot of outside air, and we have these pollutants in there that we got to look at and make sure that the occupants in the building are in a healthy environment. So we went to higher amounts of outside air in some situations, greater amount of CFM per person, and then the COVID pandemic came about, and it became even a higher amount of visibility on indoor air quality. So it was about better IAQ, lower TVOCs, which are total volatile organic compounds, odor emitting compounds that might be in buildings, and particles as well. So, you know, what I'm here to say, and what I think we all know, is we can have both. They don't have to be a choice. Now, there are some things on the right-hand side here that make it tougher to be efficient on the other side, or as efficient. But the point is, we don't have to give up, and we shouldn't give up building efficiency. But we have to be aware, let's say, of what's going on in the building and how it impacts the people in it. So I'm going to just spend about 3 or 4 minutes, maybe 4 minutes or so, on the well building standard. You know, to review it. Some of you probably are very familiar with it, but just to hit the highlights. And really, it was started by what's called the IWBI, or International Well Building Institute. And as I said, it was more to transform the way buildings are built to make sure that the people inside are in a healthy environment. So it was about, as you see down there, about improving comfort, driving better choices, you know, with regard to health and wellness. So it really has 10 different areas in it that you have to abide by if you're going to go for the WELL standard. And as you see, air is one of the higher ones with regards to points. It's much like the LEED standard, where there are points accumulated to get to certain levels. The difference here is that you have to have points in all areas. There's a minimum amount in all areas. So, but when you look at this a little closer, what you'll see there is there's about 5, I think, that relate to a building design when you look at it from an engineer standpoint or an architect standpoint. And that is with regard to air, water, light, the thermal comfort, and sound. A little bit on materials of construction that you use, but those 5 areas are really areas that an engineer and architect are involved with in the design of the buildings, whereas the other 5 are really incumbent upon the owner of the building or the landlord, or whether it be owner occupied, when it comes to things like nourishment, movement, mind, community. these are things that they provide more from a HR concept, I would say. So, you know, we're going to spend time today on air and air quality, but you see the other ones that are applicable as well. So much like LEED, it has a scoring matrix as well, whereas you see you've got certified silver, gold, and platinum. Very much the same, 100 points total, and depending on how many points you accumulate, depend on what level that you achieve. Just to give you another sense, this is a year old, but this is again from WELL, and it shows you that how many projects are either certified or have put in for certification, and how many countries and how many WELL APs, which have grown significantly. So much like there's a LEED AP, there's a WELL AP that you can get certified to be a you know, a WELL AP and get involved with whether you're with an owner or whether you're with an architect or engineer or even a vendor. We have some of our representatives that went and got their WELL AP. But the reason I put this out is because being here in the Midwest, being in Chicago, and I handle the central part of the US along with managing some other of our regional directors, you don't see as much of it in the central part of the US yet as you do on the coasts. A lot of this, even when you think back to LEED, a lot of it starts in California and out west and New York and the East Coast. Again, very high energy rates out there was one of the reasons that LEED was prevalent out there. But the same thing, there's a lot of densely populated office areas. And then you see it moving to the central part of the country. But, you know, there are consultants, REITs, enterprise, meaning, you know, building owners like you see down here, Semantic and Cundall Engineering. There's some engineering firms that actually have their facilities have gone for WELL certification. Alvine Engineering over in Omaha went for WELL. We provided Skidmore, Owens & Merrill in their New York office. Our system went in there to help them get WELL certified. So there's a lot of movement moving towards that. And there are people there in Michigan that have also adopted WELL. So kind of to end it out here about what some of the reasons, you know, to go for a WELL standard is because of the things such as talent attraction, safer, healthier environment, this better cognitive function, which we'll talk about. So a lot of companies are using it as a reason. You know, today our younger generations are really more in tune with health and well-being and helping to make sure that we're still also energy efficient. So there's things there that are reasons for it. But I'm going to say that there's an awful lot of people now, engineers, owners, that are using a lot of the WELL standards, if you will, and they may not be going all the way for the WELL certification. I think we saw that in the LEED world as well. You know, there were people that went and wanted to get certified, wanted to meet certain levels and wanted the plaque. And then there's other people that decided that they wanted to use some of the criteria there and design around it, but possibly not go for the full certification. We're seeing that even more on the WELL side, because you see there's such a big commitment on the owner side to do some things to get WELL certified. So let me start. The second thing I wanted to do was talk about some of the health and productivity studies that have been done that have led to people and building better air quality and better buildings overall. I mentioned the COG study, and it's the cognitive function study, which the original one was done in June of 2016, and it was driven by Dr. Allen and a couple of his associates there at the the Harvard School of Public Health. Dr. Allen is also the one who recently published, he is one of his associates, published the Healthy Buildings book, which has been on the New York bestseller list. So what his studies, which were done up in Syracuse at the Carrier Center of Excellence, was that they measured different people's responses in a green building or healthy building versus a regular design, and they really got to see that, there was as an example, there were different decreases in productivity and cog function in the buildings that weren't controlled and weren't providing enough CO2. So as you see here, for every 400 ppm increase in CO2, meaning there's not enough outside air coming in, there was a 21% decrease in productivity. TVOC, same type of thing. When there were higher bottled organics, again, decrease in productivity. So this was the first study that was published that actually started to quantify the differences between people's capabilities in a green or healthy building versus a standard design, if you will. Another study and these that I'm talking to are leading you to some of the things that are important in well design and even in post-COVID design. And the importance of particle monitoring became very prevalent. The reason being is that small particles are the ones that can gather or handle the viruses. They have the viruses that we've, as you see with COVID-19. Now understand, there's no system out there that can determine or measure for viruses per se, because that needs to be done by taking samples and looking at them under the microscope to see if they're viruses. But what you can determine is the particle levels. And so this is called PM 2.5, which is 2.5 microns, or 0.3 to 2.5 microns. And the higher amounts of particles in the air can lead to an increase. In this case, this was specific to COVID-19. So this was a lot looking at both outside air, and it was also related to, again, inside air. Outside air being high particles coming in, and if you're not filtering enough out, the particles get into the spaces, and the particles are what can accumulate the potential viruses. The other thing that came to light, and the studies were done by another person from Harvard, the Harvard Medical School, and it was Dr. Stephanie Taylor. And her focus is, she had been more involved with healthcare per se, but then it got moved into healthy buildings, and showed that when relative humidity was between 40 and 60%, what happened was you had a higher incidence of infection. So that and if you think about it, if you think about those of us, again, here in the winter climates, when do people get the flu and get sick more often? It's in the fall into the winter. And one of the reasons is because the humidity in your spaces, even in your house, are down below 30%. They're very dry. And this also is one of the reasons that leads to a bacterial. So when you start looking at, and we'll talk about the different designs for air quality, these are some of the studies that were used. So to come up with some of the standards that are out there that Well and Reset and others have set. Couple other things. I could fill 5 pages of articles about about things that have been written specifically since the February-March timeframe with COVID, about how buildings. Somebody's not muted, but anyway, that have come out in the news about how buildings can make you sick, how the coronavirus is going to change how we design buildings, how offices aren't going to be the same anymore. We've seen that with schools. So there's a tremendous amount of news out there. You can get an article every day about the fact that buildings, and what are we going to do to make them safer, and let employees back in, let students go back to school. So tremendous amount of visibility on healthy buildings and what we have to do to allow the people to come back into them safely. So last, I'm going to go through some of the well and post-COVID design. So when you talk about well, it's pretty well laid out. And if we just stick with air quality, remember there's those 10 different sections, but air quality, one of the things that changed with air quality and building is that we've been doing this for 20 years. We've been in this business. And what was driving it for years was energy savings. You do things like CO2 in spaces to do what's called demand control ventilation, bring less outside air in when people aren't in there. But it was always driven by energy savings. So there were a lot of buildings that didn't do it if it didn't meet a certain ROI. And we had done a lot of it in critical spaces, which had a great ROI just because they use so much more air. Things like laboratories, they use 100% outside air. And if you can continue to use less outside air, the savings become pretty great. Very, very good ROIs. But what's switched with well is it's not about energy savings and ROI. Now, like I said, it's still important to make an energy efficient building, but what was driving it, as you see, was healthy air, healthy buildings, better IAQ, and then information about the space itself. So the air quality section in well, as an example, requires what we call multi-parameter demand control ventilation. So what that means is it had a list of 9 parameters, and you had to pick at least 3 of them. So it's not just CO2, it's things like particles, TVOCs, CO, formaldehyde, ozone. There's 9 different parameters, and it said you had to pick 3 to get the air quality requirement. When you think back to LEED, just doing CO2 gave you a point or credit, or doing demand control ventilation, but there was nothing about TVOCs and particles and any of that getting you anything extra, although some of our customers did that and got an innovation point. They did more than CO2. But here it's a requirement. If you just did CO2, you don't get any in the air quality requirements. Now, then it goes farther and it says, okay, what you also have to do is you have to annually calibrate each of those sensors. And you have to submit it annually to maintain your air quality credit. So what's different about well is that you have to prove and do things every year, and then every 3 years they come back out and inspect what you're doing in order to keep your gold or silver or what level you made. So it's not you do it once, you get the plaque, and you're forever gold like you can be with LEED. Here you have to do things every year to prove that you're doing the right thing. And so here it says you require annual calibration, and the data has to be able to be analyzed regularly, and it's hosted either on a website or a phone application. So these were all requirements that, again, got you additional points, and were required, once you got to those points, required to do that and prove it annually. In the thermal comfort area, these are all part of the air quality section. In the thermal comfort area, you've got extra, again, humidity was a point for operating at 40 to 60% during occupied hours. So, there were things about temperature and a whole list of other things with regard to the thermal comfort area. So that was some of the things that made well a really great market for us, because this is stuff that Aircuity does. But now let's talk about post-COVID. The difference between post-COVID that I have seen versus well is that safety became a higher focus. It's become the owner's major concern after COVID-19, and whether that owner be a superintendent of schools, or whether that owner be a landlord, or that owner be an owner-occupied building, they wanted to make sure it's safe and that they had better IAQ. Okay. Oh, one other thing I wanted to go back to, I missed. I used the term better IEQ under the well market. IEQ, which is indoor environmental quality, takes into account sound and light. IAQ is just the air side, but IEQ becomes air, sound, light. So it's the whole environment that is part of what they want in well, as we talked about with some of those other categories. Here, it was about better IAQ. They focused on the air quality in buildings and the importance of information, so that you let people know, or they could find out or you published it, whether it be on a kiosk or report, information about the air quality. So what you saw is that there's been numerous articles. These are, a lot of the design strategies have come from WELL and other types. Again, not going for WELL certification, but using some of the data and some of the information from the studies to make some design decisions. So, and again, you saw a lot of these articles. So there are a lot of articles that talked about it. There are a lot of engineers even that published articles about what to do. And one of the first things that have been talked about is better filtration. Now understand, none of these we're not after points or anything like that. We're after decisions on how to make this building healthier. So better filtration and upgrading the filters, because I talked about the particles and were a big issue. Some people are looking at virus mitigation, looking at things like bipolar ionization or UV lighting. Cleaning strategies have been upgraded, but again, be careful there, because when you're doing cleaning you may have higher VOCs. And then the other part of it became the potential to now measure what's going on and provide demand control ventilation in a different type of setup. Meaning, by different, I mean, here they're looking at, excuse me, possibly bringing in more CFM per person, okay? Because ventilation, and there's all the studies and discussions about more ventilation allows less of the particles to settle out or to stay active, so that other people can potentially catch a virus because of the higher particle levels. Humidity control was the other thing that was most people were looking at as well, because of what I said. Now, the last part of it, and what we're really setting the table to talk about a little bit here, is feedback and insight. So the whole point here really becomes the ability to measure, manage, and communicate air quality. So the whole point is, some people look at, well, I'm going to put in bipolar, or I'm going to do UVC, I'm going to include higher filtration. But the whole point is, if you're not measuring what's going on, how do you know you need that? Or even more so, how do you know it's working? So really, it's about a key part of it that some people forget about, is the fact that you got to measure and see what's going on in the building, and then integrate that information into the building automation system, so that they can make choices about more humidity or more outside air because there's a higher level of particles, or time to change the filters, or time to do service on that bipolar ionization system. So the whole point is, the key aspect to make sure that you are providing a healthy building is to be able to measure what's going on and then communicate it over a platform that has some intelligent analytics or intelligent information that goes either to the building owner, and even as far as being able to be accessed by the people in the building themselves on a mobile device. So it's really about being able to measure, manage, and communicate air quality. And so people say, well, what should we use as the standards? Well, most people are turning to WELL because they've done studies and they've published standards with regard to every one of those parameters they have. There's a target of being less than a certain amount. And carbon dioxide, even from the standpoint of the lower CO2, means you're providing more CFM per person. So the whole point that my new favorite slogan is, you can't control it if you don't measure it. How can you meet a target, or how can you know that your filters or bipolar or whatever you're doing are doing what they're supposed to if you're not measuring what's going on in the space? So this is where we come in, and others come in. There's more than one choice, and I'm going to talk about that and show you some of the options. So when we talk about measuring, there's things about controlling based on outside air condition. Verify that you're bringing in the right amount of air. provide the right amount of air per person, provide more air when it's needed because you've got a high TVOC event or potentially high particle levels. So the whole point about this situation is that the monitoring is a critical aspect along with whatever strategies you're choosing to use to help mitigate it, make it better. Whether it be better filtration or whether it be adding a bipolar or whether it be, let's see how it is right now. Maybe we're doing good enough now and meeting those standards that I put out there. And then an important key part, like I said, is communicating it and having the ability to communicate it to the people in the building if they want. By if they want, I mean it's available, or it should be available on either a mobile device or a laptop or a iPad or tablet type device, so that the information will always go to the building management system because they're using it to make control decisions, right? But the other aspect of it is to have it available on that cloud for other constituents that may want to see, or put it on a kiosk, put it on the wall on a screen, a big screen, information about the air quality. So let's talk about some potential commercial IAQ strategies, because the commercial building's different than owner occupied or a school. There they have what we've been working on, and others are that step one is to validate the core and shell and the air quality. By that I mean they want to make sure that the landlord is providing the right amount of high level air quality air to the tenant spaces. And then the tenants do also add things, but they want to make sure that they're using stuff that's accurate, so they can say, in case the tenants aren't doing anything and are saying, or they've got inaccurate data, or people have something on their phone that they buy from Amazon that's supposedly looking at the air quality. So the whole point is, step one is to do the core and shell and monitor the supply, the outside air and the supply and return air that's coming from the spaces. And then two, they engage the tenants as they come in, and engage the tenants to be able to understand what they want to do, if they want to monitor their own air and own spaces, and how they want to communicate their air quality strategy. So here you see, as an example, just measure the sampling locations, looking at things like CO2, CO, TVOCs, particles, as I said. So you're measuring the outside air, and you're measuring before and after the filter bank to see how it's doing, and you validate that the air delivered to the tenant spaces is what it should be. From the tenant standpoint, then, they come in, and usually it's up to the tenants as part of the fit out to say how many areas, what do we want to do as far as air quality monitoring on our standpoint, because obviously the landlord isn't looking at the individual spaces, they're just looking at what's being delivered. So what you oftentimes see in the tenant fit out is to measure open office areas, conference rooms, and then other critical zones. And if you're going to take a look at what you usually see, again, this is from Well. I think Well says every 3,000 square feet. So that's why we see a range of 2,500 to 3,500 square feet. That's a sampling location. And the green dots there you see are where they're looking at things like the CO2, TVOCs, particles, etc. So that kind of is where you go in from a tenant fit out. Now, if it was an owner occupied, you just take the two stages out and you do one altogether, meaning, it's not landlord and tenant, it's that you're looking at the supply side and outside air and before and after supply and what's being delivered, and then you look at the spaces itself, because it's the same owner, let's say, if it's an owner occupied space. So how do you do this? Okay, so there's two different ways to do it. One's called discrete sensing and one's called multiplex sensing. The difference is this: discrete sensing means it's individual sensors, And those sensors, and you just see, you know, boxes up there on the left, the sensors can either be of one particular parameter, or it can be, some of them have, excuse me, multi-parameter stuff in the same box. So you might want to look at what you see here on in the multiplex. You see individual sensors. So those are the 5 different types of sensors: CO2, TVOCs, particles, dew point, carbon monoxide. Now, you could have, in some instances, 3 sensors in a space: a CO2, a TVOC, and maybe humidity. Or you could have, sometimes there's some manufacturers that put 3 or 4 sensors in one box there, as you see. So the difference between the two is that, I'll show you a picture in a minute, but this multiplex system uses a sensor suite. So you could have up to 40 spaces that are monitored out of this sensor suite that have the sensors in, by bringing the air samples back and then tying it into the building management system. Or you can have individual sensors out there that are measuring what you want in those spaces. Now, in either case, regular sensor calibration is required for well, and even for non-well. If you're not calibrating those sensors on a regular basis, they're going to drift. All sensors drift, as best ones drift. But what happens is, you calibrate them, either calibrate them annually, as well says, when it requires, or in our case, or in the multiplex case, the sensor cards are replaced every 6 months with newly calibrated sensors. So calibration is the key. I'll touch that in a minute. This is just a drawing to give you a sense of what this multiplex arrangement is. Down here where it shows sensor suite, right here, that's where those sensors are, okay? And in the room itself, whether it be out of the return air or on the wall, there's a probe, and that probe is bringing air back. Doesn't have sensors in there. It has ability to bring the air back one at a time through these routers, and is being looked at here, and then the information goes to the BMS system. Difference here is, you're maybe you're looking at this room maybe every 10 or 15 minutes, depending on how many rooms you have on it. But for these for what we're looking at, that's fast enough. This isn't doing temperature control. It's just doing the monitoring of those parameters that we say, and they don't change every minute. They change over time, and then if they get too high, then you do that. So this becomes a way, another option, rather than putting the individual sensors. So the discrete sensors then, which look like this, they're put at each of these dots. So in the multiplex system, there's a probe that's bringing the air back to a sensor suite, and in this case, there's a probe. There's sensors out here that are wired directly back into the building management system, and they're reading the parameters and making those decisions. So the key is that you could have 3 or 4 or 5 individual sensors at each of those dots, or some of these that have one enclosure there with 3 or 4 or 5 sensor elements in there. Either way, you still got to get it calibrated. So in the case of the multiplex system, what happens is those sensors are sent back to a calibration depot, and they're cleaned, and things are replaced, like the infrared lamp. They're calibrated over multiple values using this NIST traceable gas, and then they've got a calibration certificate. So what happens is this calibrated sensors are sent out, the other ones are taken out and sent back to be calibrated, and then those sensors go out to somebody else once they're calibrated and meet the specs. In the field, what happens is that you actually go to the sensor. You see, there's a sensor on the wall there, and it doesn't take 2 people. Sometimes it does, I don't know. But this shows 2 people there. You're either giving it a gas, you're measuring what the actual measurements are in the space, and you're resetting it, or what you need to do is adjust it based on the instrument that you provide, and say a calibrated instrument is there, and here's what it's saying, and now you change the calibration to that. So it depends on the different type of sensor, but they have a calibration requirement and a calibration interval. They also have the ability to send that back to the factory, but that means you've got to have a whole nother device that you put on there in the interim. So you've got to have spare sets of these to swap them out, or more commonly, it's done in the field. But you have to go to every one of those 30 or 40 or 100 or 200, however many there are in the building. One other point on the multiplex system, it showed one of those sensor suites doing 40 rooms. If you have the buildings like we have with 400, 500, 1,000 different points, in a multi 50-story building, you just have more and more sensor suites to equate to that 1,000 number, if you will. So calibration is a big requirement that you've got to make sure is done. And then, what do I say? You can't manage what you don't measure. So you ought to be doing some level of monitoring in the spaces so that you can provide the information that's needed. So to wrap up here, we know we need to design, provide safe, healthy, energy efficient buildings. And I want to make sure that we say energy efficient, because we can do all we can to make things energy. There's different things you can do to still make it as energy efficient as possible. And together it drives us to deliver improved strategies, do some things that are different. The technology exists today, let's take advantage of it. And also, it requires all aspects of your building people, the design people, the engineers, the designers at the whether it be the landlord or owner operated, or at the schools, higher ed, and the operations side, because they've got to be a part of it, because this calibration is a key aspect and cost. So, there's plenty of, the term intelligent systems is pretty common. The last thing I want to make sure that everyone understands, that we believe, and I think most people do, there's no one technology that's a silver bullet. You can't say, oh, I'm going to put this in and I'm okay, I'm done. It's good forever. It requires a comprehensive collection of solutions, and those decisions are made by, usually the architect engineering community in conjunction with the owner itself. One last thing to give ourselves the one plug here, hopefully, is that we've been doing this measurement and control of IQ for 20 years now. We had a portable device that we sold for 4 or 5 years. For 10 years or more, we've been doing critical environments and universities and healthcare and stuff. And we've also been doing office buildings for that same amount of time. It's just that today it's become a higher focus for people. And so we'd like the opportunity to work with any people there. Kyle, and there's a team of very good salespeople there at Quality Air. Kyle's a good contact in the Kalamazoo office, and there's people in their Detroit office as well that not only represent Aircuity, but filtration and other things that are critically important to the success of the buildings. So with that, I'd like to thank everybody and for attending today. I hope you got a nugget or two out of this, and we'll open it up for questions.
I'm sure we got more than a nugget or two out of this. This was an amazing presentation you put together.
Thank you.
Yeah, it was phenomenal. I was taking notes for myself personally. So folks, I see that people are really chatty in the chat. Thank you so much. So there's some Q&As coming through, and right now as the presentation is going forth. So now that you've seen everything, folks, if there's a question that comes to mind that you really want to put in, now's the time, and I'll make sure to get to them as best I can. So let's, where to start? Okay, well, let's honor the early bird questions. So folks, for you who have been coming through the Healthy Building webinar series, or maybe the Cannabis series for a while, you know that we give you the opportunity to send in questions ahead of time. And we call these the early bird questions, so that Pete or whoever the speaker is has an understanding of what you're curious about, and they can make sure to answer that throughout their presentation, as well as we include these as a piece of the live conversations themselves. So this question comes from Perry, and it asks, when measuring indoor air quality, what do you consider the minimum quality and what defines the quality? Temp, humidity, CO2? Yeah, for sure. But what else? Maybe particles, odor, etc.
Yes, I think you go back to, and again, I didn't talk about temperature because temperature is done the way it's classically been done with building management systems. But you saw that besides the ones that Pete, was it Pete? Was his name Pete too?
Sure.
Oh, Terry. So anyway, you see the TVOCs and particles, CO was on there. I don't say that CO's looked at all as much. It's one of the parameters, but when you talk about the three parameters that most people are looking at, it's going to be CO2, TVOCs, the total volatile organic compounds, and particles. Those are the three most common. And like I said, those are the ones that are also identified by well with certain targets. The other thing is that the other five are listed at the well, in the well area, formaldehyde being one, but formaldehyde with a good TVOC with the PID, which is a photoionization detector, formaldehyde or formalin can be picked up out of that. So those are the most common ones that are done. The only other one that people sometimes bring up is ozone, only because some people believe that some of the bipolar stuff emits ozone, and that can be added as an individual type sensor. But most people don't do that as much because today I think the bipolar people have convinced many that they may not, they don't, some of them don't produce ozone.
Oh, yeah. Yeah, I've heard about that too. We had a bipolar talk going deep into it a couple months ago, I think by now. We're so deep into 2020. But it was a really great conversation about what are the perceived benefits of VPI, what are the perceived negatives, and how you balance that, and how to dive deep into that. I think Tara Pinkster actually did a really great job on that. And so folks, if you want to listen to this recording or any of the recordings of the previous webinars, you can find it on our YouTube page as well as on our website. And if you're having trouble finding any particulars, feel free to email me. I'll make sure to get them to you. That segues well actually to another question that had come through, and it asks, have you seen Aircuity, or what it just says IAQ, real-time sensors be used to compare technologies such as UV, BPI, MERV filtration?
Exactly. Yeah, that's exactly what we've seen. I'm not sure you can tell as much about the UV success through, we're still trying to do some testing to see that, but most definitely bipolar and the filtration. I mean, there's different ways to maintain, and Quality Air is an expert in filtration. They've been doing that since '77, but it's another look. In other words, they look at differential pressure and things like that, but you can, by looking at particles remotely, it helps with bipolar and the filtration itself. And the key is you want to get, Aircuity uses a laser-based particle counter, high-level particle counter. That's one of the advantages when you can do 40 rooms out of one sensor, and there you can really tell the difference. And so you got to look at the sensors that you put in and understand what their capabilities are to look at. But it does make a difference, and again, half of it is letting the landlord and the employees or the tenants or the students know, hey, it is healthy. Look, we have lower particle levels. So if you put better filtration in, you go from MERV 9 to MERV 14, unless you're monitoring downstream in the space, who knows if it's any better? And it will be, but how do you prove it? So that's definitely part of the rest is to be able to measure those and be able to communicate that the environment's better because you've spent the money to upgrade your filtration or add bipolar.
Right. No, there's two ways I can take this conversation now, but I think before we go into Drew's question, I want to follow up quick with, you were explaining this, what these measures, what the sensors measure,
yes.
Buildings. And I know that, especially right now, people are concerned about being able to pick up like particular bio information such as bacteria or viruses. So does Aircuity detect viruses, or what do they detect in order to indicate there may be a virus present?
So no sensor is out there today. Hopefully, tomorrow or, next year will be different, but there's no sensor that can detect a virus per se. And that's why small particles become the proxy, if you will, for whether or not, viruses can be prevalent. So it's one of these things that it's kind of like when you think about filtration and clean areas, when you think about OR suites, they HEPA filter those suites. And the reason they HEPA filter it is to make particles as a very minimum, as clean as they can, because they don't want any bacteria or virus prevalent while they're operating on doing heart surgery or knee replacement or hip replacement. So by making particles lower, it's less likely that you will get an infection. Well, it's the same things taken over now to the building side. Now, we're not going to HEPA filter. Filter people might like that, but they're not going to HEPA filter. You're not capable of HEPA filtering commercial spaces, but you're capable of making the filtration better to have less particles and then have a better chance of not promoting a virus there. Less particles, so when that person unfortunately sneezes and all those particles go out there, that they fall to the ground and they don't grab onto another particle and stay airborne for a longer period of time. So we don't know if those particles have any viruses, but we always know that we want to measure that PM 2.5, that small level, because the less of those that there are, the better off you are. And we can't actually determine the virus if a virus is present.
And that's why when someone sneezes and you want the particles to fall to the ground and not get concentrated in the air, it helps with the humidity of your building. So that's another one that we've done before, folks. So you can look at that as well.
And the ventilation level. That's the other point, is if you're bringing enough ventilation in, you're moving air through there. The studies showed that low ventilation levels meant that the particles stayed airborne. There was a study that showed, a video actually, that showed that they could stay airborne for 20 minutes, 30 minutes longer, because there's not enough ventilation movement, which keeps those things moving through and get exhausted out the return air and etc. So it's a combination of right or more ventilation and less particles are going to give you a better opportunity to have a healthier space.
Absolutely. So this next question comes from Drew. I think that it's well placed, especially with the conversation that Kyle and Gail and us had before, on that you can go through and just one and done test your building and see what's in there, or you can have continuous feedback loop, right?
Right.
She asks, how robust are these sensors? How often do they require maintenance or replacement?
Okay. Well, that's a great question, because, that's the key. If you're looking at individual discrete sensors, you really want to look at the specs and see how good they are. And I don't say ignore, but they usually don't tell you how often they have to calibrate some of those sensors. But that's where Wells come in and said, we need to do them at least annually. Now, if you go into the other sensors, the multiplex, the advantage there is they're much higher grade sensors. They're laboratory grade sensors, because you can buy one set of them and do 40 spaces and therefore have a higher grade of accuracy and resolution. So there's specs always on each. We have chosen, because of what we've seen, to do calibration every 6 months. It's really the TVOC sensor that needs it every 6 months, but we do them all at one time. So sometimes you can go longer with a CO2 sensor, but I really wouldn't go much longer than 9 months or a year. So the robustness is the key, and that's where you want to look at the specs on the sensors and assume that they need to be calibrated at least once a year. And we recommend every 6 months because, you know, we've been working with sensors for 20 years and we get them back every 6 months and we see that they're drifting. They're already drifting out. And these are the higher grade sensors. Every sensor drifts. So you've got to figure in calibration in the cost. If you just look at the first cost, that's not, you know, what you want to look at is a life cycle cost and say, yeah, what's it going to cost me for these sensors from a replacement and or calibration basis for 3 or 5 years? And sometimes that isn't done, unfortunately, and they just look at first cost, and that's a huge mistake because you can have a calibration costs be, you know, think about a building. We've done one building that had 2,000 sensors in it, the new Apple World headquarters. And can you imagine how much labor that would have taken to keep 2,000 sensors calibrated? You know, unfortunately, there aren't that many big buildings that size, but even when you get into 40, 50, or 100 sensors in a building, and now you're looking at multiple sensors for each space, you know, 3 or 4. So it's pretty quick to get up to that 100. That 100 area is 20 or 25 spaces or more with 3 or 4 sensors per space, and they each need to be calibrated.
And so, Pete, before we end at 11, I've got one last question for you.
Okay.
And it's more of a big picture question. It asks, are there well-certified buildings in the Midwest region that stand out to you? But I'm going to combine it with other question. And do you know which, if any, certifications require or encourage regular IAQ testing? So do you think you could answer those in maybe less than a minute?
Yeah. I don't know. You know, I cover such a big area that I don't know. I think Michigan, I believe Steelcase has one. I don't know the ones in Michigan, but you can actually go to the USGBC website, IWBI website, and you can put in the state and you can find out which ones have certified right in there. And I know there's a couple that are working on it. And what was the second part? I'm sorry.
Do you know which, if any, certifications require or encourage regular IAQ testing?
The well does, you know, well and reset both do. So that's part of what you need to do to get the well certification is to do any point, the key points out of air quality all require that they have to be calibrated and wells recertified every year. You know, they certified on a annual basis, those well buildings.
For sure. And I think I had seen something from Renee just now that LEED also has just required air quality testing.
Oh yeah, that's right. They have.
Yeah. So thanks for that heads up, Renee, and thank you, Pete. And to Sherry's comment earlier, there is a exciting well building that's about to announce pretty soon here in West Michigan. And we're going to be having a webinar soon hosting them. So please stay tuned for that. We're thrilled to be having them on the webinar series. And thank you. Thank you so much, Pete, for coming today and talking to us about Aircuity and air quality testing. It's come so far in the last couple of years. It's amazing. So folks, as you know, we try to end on the hour. But before we go, I want you to know that there's going to be a survey coming through. And it's really important to us that we hear your feedback. It's going to be coming either from Wendy or maybe the USGBC of West Michigan. But fill it out. It's super simple. And this is how we get the content that you want in front of you. Thank you very much to our visionary sponsors. Thank you again to Quality Air. And to Pete, thank you so much. And the attendees, if you need anything, you know where to find us. And I hope to see you next week. Thank you very much, Pete.
Thank you. Have a great day.
Take care, everybody. Have a good one.